Section 7.2, number 27, we need to solve this triangle where we're given just the sides. That's side, side, side. And when we solve a side triangle, we don't have any angles. That means we need to start. The first step is to use the law of cosines to find the largest angle. And then we can move on to the law of sines to find a second angle. Doesn't matter which one. And then we finish by finding that third angle using the triangle sum theorem. Okay, so we use, for first one, we use the largest angle because when we use law of sines, we get that ambiguous case when there's the possibility of having an obtuse angle, because then it could be obtuse or acute. Sine only gives us the acute angle. So we're going to get, if there is an obtuse angle, we're going to get it out of the way now, because there's only, if a triangle has an obtuse angle, there's only one. So we'll get it out of the way using cosines. The law of cosine. The law of cosine will give us an obtuse angle. So, or acute. The law of cosines will give us whatever we need. Okay, so let's do this first one. First step in blue. So the law of cosines, I could start largest angle. So that means I want to go the largest side. So largest angle is across from the largest side. Why is that still black? There we go. So that's going to be angle A. So angle A, I find using the formula for the side A, because angle A will be at the end of that. So side A, law of cosine says, A squared equals the sum of the squares of the other two sides minus 2 times the product of the other two sides times the cosine of the angle I am looking for. Okay, so to solve for A, subtract the B squared and the C squared. And this stuff we'll have to deal with on a different step, because that's all being multiplied together. That's one big term. So for now, all we can do is subtract B squared and C squared. And we get A squared minus B squared minus C squared equals negative 2BC cosine of A. Now to get cosine of A by itself, we're going to divide both sides by a negative 2BC. So now I have cosine of A. I'm just going to switch the sides here, so it's what I'm solving for is on the left. Cosine of A equals A squared minus B squared minus C squared all over negative 2BC. Now to get A out of that cosine, we just take the inverse, whoops, not sine, cosine inverse of both sides, because whatever I do to the left, I got to do it to the right. And on the left, the cosine inverse undoes cosine, so I'm left with just A. And on the right, I got some plugging to do. So I'm going to look up here on the given information. I have cosine inverse of, and I'm going to plug in my A, B, and C. So A is 15 cube root of 3. All that squared minus B, which is 6 radical 3 squared minus C, 10 radical 3 squared, all over negative 2 times B, which is 6 radical 3, and C, which is 10 radical 3, and the cosine inverse of all that. So good time to get out my calculator. So this is actually the exact answer, and if I get this answer on a test, I'm happy. That is the most exact answer we're going to get. Once we stick into a calculator, it's actually not as accurate anymore because we're probably going to have to round to a decimal. So, but we'll do that. Let's see here. So I want cosine inverse, make sure I'm in degrees. I guess it doesn't matter with this one. We'll stick with degrees. Whatever you want your answer to come out as, you'd use degrees or radians, but this unit we're using degrees, so I'll go ahead and leave degrees and say cosine inverse, whoops, yeah, that's it. And then I'm going to need a lot of parentheses on this one. So first a parenthesis for the numerator, second parenthesis is for the 15 times the radical 3. I'm going to close that 15 radical 3 and square it. And then I have minus, I need another parenthesis for the 6 radical 3, close the radical parentheses, close the 6 radical, and then square that. And then minus, I need another parenthesis for the 10 radical 3, close that parenthesis, and square it. Now close another parenthesis for closing the numerator. All of that divided by another parenthesis for your denominator, which is going to be negative 2 times 6 radical 3 times 10 radical 3, and then close the parenthesis for the denominator, and then close the parenthesis for the arc cosine, and that gives me 137, we'll round it off to 9.9 degrees. So that's A. So we did, in fact, get an obtuse angle. If we had tried to do that with law of sines, we would have had 2 options and an ambiguous answer. So it's helpful that we got that out of the way with law of cosines. Now we can move on to law of sines. I do have one side and angle pair because I just solved for this side for the angle A. So I can use that as in the law of sines. So that's sine of A, which is 137.9 degrees, is paired up with side A, which is 15 radical 3. That equals the ratio of either of the other sides. So I could do sine of B, which is paired up with side B, which is 6 radical 3. And then cross multiply to solve for B. I get sine of B, I'll do 6 radical 3, sine of B equals, I'm sorry, not 6 radical 3, 15 radical 3, equals sine of 137.9, oops, I forgot the 6 radical 3, 6 radical 3 times sine of 137.9, and then divide both sides by 15 radical 3 to solve for sine of B. On the left, these will cancel, and I'm just left with sine of B equals all the stuff on the right, so to get B by itself, I'll take sine inverse of that, sine inverse of both sides, because whatever I do to the left, I got to do to the right. Get out my calculator to solve that one, so I get sine inverse of, again, if you don't have the calculator, you don't need it. If you put that as your final answer, that is correct. That is the most exact it is. At this point, I'm going to be making it less exact by rounding it to a decimal point. So arcsine of 6 radical 3, close the radical, times sine of 137.9, close the sine, all divided by 15 radical 3, close the radical, then close the arcsine. Actually, I forgot one parenthesis here. So the denominator needs a parenthesis, so I'm dividing by 15 times radical 3, so both the radical 3 is also in the denominator. So there's another parenthesis there, so that gives me 15.6 degrees for B, approximately. And then, actually, I'll go ahead and leave the calculator out so we can find C easier. So I have A, angle B, and I need to find angle C. So C is going to be 180 degrees minus angle A and minus angle B, which is, oops, clear, that 180, whoa, yeah, it looks good actually, 137.9 and 15.6, which equals, and it's approximate since we used approximate values for A and B. So I'll still say approximate even though I don't actually have to round for this one. So that completes my triangle. I now have side A, B, and C. And I was already given side A, B, and C.